So in today's video, we are going to carry on working on our enemy, our spider enemy that we started in yesterday's video, I believe. And today we are going to start making it so that it moves not only in one direction, but now when it reaches the end point in the direction it's currently traveling in, we're going to make it move back to its original point. And then later on, we might, depending on how complicated we want to get with the enemies, we might add in more points for it to move to. So say, for example, it can start at point A, move to point B, stop there for a few seconds, then carry on moving along to point C. Or like in today's video, we're going to make it move from point A to point B and then possibly pause there for a second and then move back. But I think we'll start with just having it move back straight away, as well as flipping the sprite itself so that it actually looks like it's moving in the correct direction or walking in the correct direction. So let's jump into it and start that out. So yesterday's episode, or the previous one, whenever that was, let's see, where's our scene? Okay, so here's our spider. We start the game because I think it's did it fast. So our spider starts over there and it moves in a straight line towards the second point, which point A, point B. Okay, so we manually hard coded the numbers. We're not going to do that. We're going to change that in today's episode, just so that it is easier to change. If we want to change where we put our enemy, we can change it easier and not have to figure out what numbers we want to use. So we're going to start by doing that first. So let's go and get rid of our animation tab for now, because we don't really need that at this point. We're just going to work on this enemy here. Now, just bear in mind, if you're new here, please go ahead and subscribe to the channel if you like these videos. And if this is your first video, we are currently making a simple 2D platformer, and just bear in mind that this is not the final level design. We're just using this to set up most of our animations and our game objects. So we are currently working on our spider. So we're going to make it move from this point here where it is. So let's go and add a point A to that. So let's go and say point A, and we will place that on our, where is it? So here it is. So we can go and place that over here where our spider is, so somewhere over there. Now I'm going to duplicate that, and I'm going to change the name to point B, and then we can just go and move that to the opposite side. So now, instead of using on our spider, I think they're integers that we used in our spider. Oh no, they're floats. So we used floats we used floats as references to where we want the spider to move to. So we're going to change that up today, and we're going to use game objects. So we've created our point A and we've created our point B. So now let's go and replace float with game object, and that's also going to be a game object. And then we can go get rid of the 19 as well as the 10F that we set earlier. So we'll save that. Now we can go and get rid of this for now. So let's go and actually we can leave it like that. So instead of saying point B, we can now go and say point B dot transform dot, I think it's going to be the X value. So we'll leave that dot, what is it going to be? Position.x. Yeah, that's what it's going to be. So save that. And then where are we? Okay, spider. So now we can go and drag these in. So let's go to our spider, and for point A, obviously we're going to drag into point, did I drag the wrong one? Point A into point A there, and then point B into point B. Now I'm just going to switch those around because I don't like point A being at the bottom. It just looks weird. So that should be fine. Now I don't know if we have to drag this in again, but we shouldn't have to. Okay, so point A and point B. Now I'm just going to play it, and I'm going to hope that the spider will still move to point B, which it does. Okay, then it stops. Now we need to go and work on getting the spider to actually rotate in. We're just going to times the sprite by -1, so it flips it around, and then we will carry on walking in the opposite direction. So to do that, let us go and code that out. So first of all, before we do that, just to make it more like, so you can actually see the different points and the difference, well, the journey that the spider will make from point A to point B, or from whatever point it will be. We are going to add a little visual tool to our points, and then we're also going to add in a line from point A to point B. So let's go and do that quickly, and it should be fairly simple. So instead of selecting both of our points, let's just do this for now. So we can go and add in a tag like that. So you can see point A to point B, that's where they both are. Now, we don't really want to do that because it doesn't really look nice. And we want to be able to visualize the journey that the spider will take from between the 2 points. So let's go and test something out. Now, I've never done this before, but let's go and see if it actually works. So in our spider, I think it's in our spider's class. So on here, let's go and create another method, and this is going to be a private void, and then this is going to be a on draw gizmos. So this basically draws a wireframe around the game object or whatever you want, so that you can be able to visualize it, and you can only visualize it when it works in the scene window, I believe. So when you actually play the game, it's not going to be in the game. So it's purely just for development purposes, so you can visualize things without having to actually change things in the game. So let's go and say gizmos or whatever, however you say that. Gizmos.draw. What do we want? We want a We want a sphere, wire sphere, because we only really want the outline of it. So draw wire sphere, and then we're going to say point A dot transform dot position. There you go. And then we have to give it a radius, so how big we want it. Let's just say radius, and then let's go and create that, because we're going to need the same thing for the point B. So here under float, let's go and say private float radius is, that's going to be equal to 0.3 f, because it's float. And then we can just go and duplicate that, and then instead of saying point A, we can go and say point B, and then that should be fine. So let's test that out and see if we get anything. So there you go. Now let's go. Now that we've got those spheres or the wireframe, we can go and get rid of that. So you can see that we now have, on each point, we now have this wireframe drawn around them, so we can actually see where the path is. So now let's go and join them up by saying same thing, gizmos dot draw line, and then we want it to be between point A dot transform dot position, and then we want it to go to point B dot transform dot position. So let's test that out. Now we should get a straight line from point A to point B, just like that. So now there you are. There you have it. You can see the journey that the enemy, in this case it's our spider, will take from point A, which is over here, and then it's going to go to point B. When it reaches point B, it will then eventually turn around and head back to point A. So that's just a little way of visualizing the journey the spider will take. So you can't really see it, but if we navigate our way to the spider in the actual game itself, you'll see that there is no line or there is no gizmos drawn. It's only in the scene view. Okay, so now let's go and start working on having the spider actually move back to the opposite point once it's reached the secondary point. So we want it to move back to the first point. So how are we going to do that? Let's go back to our script. So we've got here, when we reach point B, then we go, or when we're saying here, when our current position is less than the position of the second point, we need to go and travel to it. But now we need to say if the position is, I think it's, what is it? It's going to be, let's see. Okay, so let's change this up. Let's make it so that do we have a rigid body? Yeah, we do. So let's use our rigid body instead of translate. So let's go and say if the current position is less than the point B position, then let's go and say rigid body dot velocity. Let's test this out. I don't know if it's going to work, but let's test it out and see if it works. So rigid body dot velocity is going to be equal to new vector 2, and then we want it to be on the x-axis. We want it to be, do we have a speed? So it might be a bit too fast, but let's say speed, and then on the y-axis is going to be 0 because we don't want it to move up. So let's go and test that out and see. So let's see if that works, and even if that does work, I don't know if it's going to stop there. Okay, so now it's not going to stop there. So let's see. Let's go and say now we need to add in an else statement. So else, if I can spell correctly, else we need to go and say rigid body dot velocity is going to be equal to new vector 2, and then we're just going to have negative speed. So when it reaches that point, we want it to move back speed. And then same thing, the y is going to be 0, and then let's save that and see if we get movement in both directions. Now, before we do that, let's go into our spider game object and let's go and change a few things in our rigid body. So what we want to do is we want to freeze our rotation on the z-axis so that we don't have the spider rotating. Now, if we play it, you can see that it does not work correctly. Okay, so let's see. What do we have to do here? So let's see. So first of all, let's reduce our speed of our spider to something less so that we can see it. So I'm just going to make this private. Otherwise, I doubt it is going to change the actual speed. So hopefully that's a little bit slower. Okay, so our spider is now moving from point A to point B, but now it's getting stuck there and it's trying to move. Okay, so now we need to go and flip it. Okay, so let's go and see. What do we want to do? We need to, let me just check my script here. Okay, so let's add in a check. Here we can go and say, oh, we've got another subscriber, Stephen Brand, lucky. Thank you for subscribing. If you're watching this, you subscribe at the correct time while making a video. So thanks for that. I do appreciate it. So let's see. What are we going to do next? We need to get a check. So we need to check to see if our spider is moving in the correct not the correct direction, but the right direction in this case. So it's going to be moving from left to right, which means it's going to be moving into the right direction. So let's go and say let's say private boolean. This is going to say direction right, and then we're going to say equals to true because it's going to start off by moving into the right direction. Now let's say if the transform the position.x is less than that, then we need to move it into here. Then we can go and say direction right is going to be equal to true, and if it's not, then the direction right is going to be equal to false. Okay, so that's fine. I'm going to get rid of this because we didn't get that to work, and I have a different way of doing that, and we'll do that in one of the other episodes. So I'm going to get rid of that and just play this to make sure we don't have any errors. It's not going to change anything yet, but let's just see if it... Okay, that's different. That shouldn't happen. Not that I... Okay, so that was weird. It just suddenly stopped. Okay, so it's working how it was working before. Now, let's see. So we have an enemy that is moving into the right direction. Now we need to swap it over so that it moves into the left direction when it is when it has reached point B. So how are we going to do that? Let's see. Okay, why is this not working? This should work. This is exactly what I did in our previous first attempt. There might be something that I'm missing here. Okay, so let's see if the direction is right, then translate it into the right direction. Change the direction of enemy transform.local position.x is greater than or equal to max x. That's false. That's a bit strange. Might have to go and do some playing around in this, because there's no point in sitting here and trying to figure it out. Just wasting both of our times. So I will probably have to do that then, because I'm looking at my previous script for the other game, or first time we made this script, and this is what we did and it worked. Maybe it's because we are doing this differently. Maybe it's not working correctly, or at least how I thought it was going to work. But we're moving into the right direction. Then I have a feeling it's got some kind of bug over here, because it's trying to continuously move into that direction. So let's see. Let's go to our script here, and let's go and say if the transform the position of .x, so that's the spider's that's the spider's position. If that position is less than the point B dot transform to dot position dot x, then move it towards that position. Now, if it is greater than that, which let's try and put greater than, less than, or equal to. Maybe that is why. Hopefully, I'm hoping. I doubt it, but because it was supposed to reach that, and then no, once it gets there, it should be the same value. Point B and the spider's point B x, yeah, because it's both. Well, now that it's currently moving back and forth, it is not going to be a, what's it called? A whole number. So let's see. Maybe I forgot to change a few things here. So let's go to our spider and change a few things. So on our spider, we want it to be dynamic. Then we also want it to be interpolate, I think. And then let's change that to continuous. And then I think that should be fine. Now, not that that's going to make much difference. Let's just go and test it out and see. So we've got our scene. It moves from left to... Okay, well, I don't understand why it keeps pausing there. Maybe I also need to figure that out. Okay, so that is... I'm going to go and figure that out, because I don't know why that's happening. But I will come back in tomorrow's episode, or not tomorrow's episode, because I'm not going to be releasing an episode tomorrow. So maybe on Monday, or whenever the next episode of this game is out, we'll fix this issue, and then we will carry on building our level out, because we have to fix the rule tile where we started working on our spikes, and then we need to get that sorted out, and then we will start actually putting like game objects into the game, like trees and other things, to make the level look nice, so that it's not just a boring test level. But yeah, that's going to be it for today's episode. So if you haven't done already, please go ahead and hit this button over here and subscribe to the channel so you don't miss out on the next video, and I'll see you guys in the next episode. So goodbye.